In the previous Gracie Academy video on the fundamental theorem of calculus, we looked at this formula here and how we can answer questions of this form. And if you haven't seen that, please go and watch it. The link to it is in the playlist Fundamental Theorem of Calculus in the description to this video. Now what we're going to do is we're going to advance this from being the integral between a and g of x to being the integral between g of x and h of x. And the way that we basically can remember this formula here, which looks hard but in actual fact is very similar to that one, is just by remembering that the integral between b and a of whatever, f of x dx, equals the integral between a and c, where c is between b and a, of f of x dx, add the integral between c and b of f of x dx. All we're doing basically there is, if we had some sort of function there, and here was a and here was b, we just introduced a point c and said that the whole area is equal to this area add this area. If we do this to this, then we can rewrite d dx of the integral of g of x to h of x of f of t dt. We can rewrite it as d dt of between h of x and a of f of t dt, add ddx, pardon my apologies, ddx of the integral between g of x and a of f of t dt, and both of these have a constant in them, and so we can use that formula. And then all we need to do is, because this one here is the wrong way round, we flip the sign as discussed in the previous video, which gives us this formula here, which is that d dx between g of x and h of x of f of t is g dashed x f of g of x minus h dashed x f of h of x. It looks complicated, but in actual fact it's fairly easy. So let's do some examples. Let's go straight to doing some examples. Okay, question number 1 here, and I've just left the formula in at the top. Anybody wants to try and do this question 1 here, pause the video now. Okay, well, it really is as simple as this. All we have to do is we look at the g, which is this one, and we look at h, which is this one, and the answer to this is g dashed, well, the derivative of x cubed is 3x squared, times by f, which is this, sorry, times, what am I talking about, times by f, my apologies, times by replacing f of t by x cubed. So all we do is we replace the t in here by x cubed, which will be times x cubed squared, minus, now we go on h dashed, which is this, well, the derivative of x squared is 2x, times by, and we put h into t, which will be x squared squared. And so the answer to that one will be 3x squared times x to the 6 minus 2x times x to the 4, which equals, taking x to the 5 out, 3x cubed minus 2. So that's very easy if we just put it into this formula, and remember that this formula is basically the other formula. Just imagine that we had the constant in the middle. Okay, so let's have a look at question number 2. Oh, here's question number 2. Anybody wants to do it now, pause the video. Okay, so again, it's exactly the same rule. So it's going to be the derivative of that, which is 2x, times by, replace the t by x squared, which will be x squared over log of x squared, minus, now let's have a look at this one, derivative of x is 1, times by, replace the t by x, which will be x over log x, and all we have to do now is simplify this. That'll be 2x cubed over 2 log x minus x over log x, and the 2 cancels out, which equals x over log x, x squared minus 1. And that's the answer to that one. Okay, question 3, and it really is as simple as just applying this formula, which is quite easy to remember. So question number 3, anybody wants to do it now, please pause the video. Okay, so again, what we're going to do is we look at this one first, and we get the differential of that, which is 6x squared, and then we replace the t's in there by that one, which is times sine of 2x cubed over 2x cubed minus, and now we differentiate that one, 2x times, and then we replace the t's by that, sine of x squared over x squared. And all we need to do now is just tidy this up. That's 3 sine 2x cubed over x minus 2 sine x squared over x. And again, that is the answer. Okay, so for the final one now, question 4. This is a slightly more difficult one, but it's still basically the same idea. So f of x equals between e to the 2x and e to the x of the integral of t log t dt. It tells us it has a minimum, and it's asking us where the maximum is. So anybody who wants to do that, pause the video now. Okay, so clearly what we need to do is we need to differentiate. So that's f dashed of x equals d dx of the integral between e to the 2x and e to the x of t log t dt. All right, we're going to use exactly the same formula, so let's go around here. So basically that is, first of all, let's differentiate that, which is 2e to the 2x, and then we replace the t by e to the 2x, which is times e to the 2x log e to the 2x, okay, and then take away, let's look at the bottom one, the differential of e to the x is e to the x, and then replace t log t with e to the x, which gives us e to the x times log of e to the x. All right, and let's just, so that equals f dashed of x equals, let's just simplify that, so that is, well, log of e to the 2x here is basically just 2x, so that gives us 2x times e to the 4x, e to the 2x times e to the 2x is e to the 4x. Sorry, that's 4x e to the 4x, because there's a 2x there, isn't there? Yep. Take away, and let's log to the of e to the power of x is just x, so that gives us x e to the 2x. Now, to find out a minimum or a maximum, then the gradient f dashed of x has to be 0, so we have to look at when 4x e to the 4x minus x e to the 2x equals 0. Okay, well, let's just factorise that. That gives us x e to the 2x, 4e to the 2x minus 1 equals 0. Now, they tell us it has a minimum x equals 0, so that's that solution. E to the 2x is never 0. E to anything is always greater than 0. So that means all we got left is 4e to the 2x minus 1 equals 0. So 4e to the 2x minus 1 equals 0, i.e. e to the 2x equals a quarter. So taking logs, 2x log e equals log of a quarter, i.e. Log e is 1. So that gives us that x equals a half log 1 take away log 4, and that is a half, or log 1 is 0, and log of 4, that gives minus half log of 4, which, sorry, just equals log of, which gives us log of minus log 4 over 2, which equals minus log of 4 to the half, which equals minus log of 2. So the solution to this one is, where is the maximum? Well, the maximum is at x equals minus log 2. Now, in actual fact, this part of the question down here is just standard finding maximum and minima. The bit that's interesting to the fundamental theorem of calculus is getting this bit. And basically, they are the types of questions that you're going to get on the fundamental theorem of calculus when you have f of x and g of x as the two limits. I hope you found this useful. Anybody who wishes so, please like the video and subscribe to the Goody Academy YouTube channel.